All right, guys, you need your journal and you need one of these yellow sheets that says simplifying rational expressions. Just focus, make sure it's right. In your journal, the title is going to be Simplifying Rational Expressions. Today is October 3rd, 2019. And then in my journal, this is going to be going on page 11. So I'm going to go ahead and open up to page 11. And this is where this would go. Again, I'm just going to put the date. I'm going to put the title here. And then on my paper, I'm going to put my name just right here so that if it falls out after I glue it in, I can get it back. So what is a rational function? A rational function, if you'll remember back, when we did rational exponents, that was anything that had a fraction. So rational just means fraction. We're doing anything that has a fraction. So for it to be a polynomial, we're going to be looking at equations like this with many terms. I'm going to zoom in a little bit. I think that that'll help you guys. Apologize if this is making it hard for you. We can cancel it out. We can cancel out terms if it is multiplied to the entire numerator, which is the math word for the top of your fraction. See how it's numerator on top, denominator on the bottom? So this is top, and the denominator is the bottom. So it has to be multiplied by the entire. Can't be added, can't be subtracted. Has to be multiplied. So the first thing we're going to do is we're going to see if there's anything that's the same top and bottom. And then we're going to check that it's multiplied. Can you see that the x squared is multiplied to everything on the top? Those parentheses means it would get multiplied to both terms. And then since x squared is the only term on the denominator, we can go ahead and reduce by canceling those out. And what we're left with is just x minus 5. You can have parentheses, but you don't need them since there's nothing being multiplied by it. Let's look at some non-examples. There's an x squared on top, and there's an x squared on the denominator. So we would like to cancel them out, but the x squared in the denominator is not multiplied by every term. It's added to the 1. Since it's addition and not multiplication, we cannot reduce, so it stays exactly the same. We cannot change it. Now the top is multiplied, but it can only be reduced if the denominator has the same term and is also multiplied. Back over here. What is the exact same on the top and the bottom? Well, that's going to be the x minus 3. Those are the same, and now we check to make sure it's multiplied. We can see that this is multiplied to this, and there's no addition or subtraction outside of the multiplication. And we can see that the 7 is multiplied to this. So these are able to cancel out. And what we're left with on top is just x plus 3 over 7 in the denominator. Now over here, it looks like we have that -3 and that -3, but the x's aren't the same. There's 2 x's here and 1 x there. Because of that, we cannot reduce, and we're just left with the exact same thing. So I'm going to just point at what's making it so it can't work. Addition is making it so we can't do it, and that 2 is not the same. Okay. We're going to do one more non-example before we do our last example. Now here, these are exactly the same. But this term, this x minus 3, this factor is not being multiplied to the entire top. It's being added. So this addition sign is why we can't reduce. We can, however, combine. We don't need these parentheses. So we can say x minus 3 plus x plus 3 over x minus 3. The x's are going to go together, still on the top. And then 3 take away 3 are going to cancel out. And it's going to be over x minus 3. That's as good as it gets. Now here, this is what you're more likely to see on your STAR test, where it's not already factored out for you. So you'll notice, I'm going to slide down. You'll notice up here you had the factored form. On the STAR, they won't give that to you. So your first step is going to be factor if possible. Factor just means we're going to look at just the numerator, which just means the top, and we're going to draw that x. The 4 is going to go in the base. The 5 is going to go in the top. My numbers are going to be 4 and 1. See how 4 times 1 equals 4 and 4 plus 1 equals 5? Now I'm going to set up my fraction. Set up the fraction. The numerator is going to be n plus 4, n plus 1. The denominator is going to be n plus 1. See where we got our factors from? And now I'm guessing that you already know what to do. What's the same in the top and the denominator? Go ahead and cancel them out. Right here, it's cancel. I'm going to cancel it out. Another term for canceling it out is just to reduce. So I'm going to go ahead and I'm going to get just what's left is n plus 4, and that's my entire answer. Good job.